engineers build models every day, specifically for any kind of machine learning algorithms, or any kind of artificial intelligence algorithm. So it has not been a recent phenomenon for sure. So engineers, organizations, top universities, they have been in this direction. And so if you see all top university engineering department, they build the AI models or machine learning algorithms every day. So as we see and talk, AI can certainly help engineers build better models, which means that there is better engineering, which results to better products, resulting into better society. So as we see, engineers use partial differential equations, experimentations, computational physics, simulations, they use statistics, they use various other tools, which results into models and various types of models. So certainly creating the better models and version result into the better ways of working and results into the better products from that perspective. So as Patrick Winston from MIT says, AI modeling is, so as we say, AI is a modeling of representations that support the models targeted at thinking, perceptions, and actions. So that's how newer and newer AI models, newer and newer versions of ML models have been there, and they have been getting utilized with the right set of background. So let's see two AI examples. So we will try to see these two AI examples. One is simple and another is just complex, right? So these examples can be classified as simple to complex examples, and when we'll try to see some of these in detail. So the first one being a learning from the thermal decay. So the data to optimize a cooling store. So that can be an example for the simple AI algorithms, usage of simple AI algorithms. And the second example, as we see, is the modeling of atmospheric turbulence. Leonardo da Vinci, so he was one of the person, as we call him, as one of the greatest scholars, scientists, doctors, painters, and everything, right? So he know everything. So he had tried modeling the atmospheric turbulence way back 500 years ago. So how he had tried putting that across in terms of the red spot on Jupiter. So that modeling can be solved, that modeling of atmospheric turbulence can be represented through the AI models, and then that's how these are the two examples. One is of the optimizing the cooling storage cooling system, and then second is how we can model the atmospheric turbulence across. So now let's try to look deeper into each of these. As we see, learning from the thermal storage decay data to optimize our overall store operations. So that's one of the example of operational research. That's one of the simple example of usage of AI in the operational research, right? So we try to use operational research to optimize the content of the thermal store with 2 volts that basically allow your products to cool down slowly. And when engineers or organization or teams or people try to put the heat generation limit, the value, the heat generation limited to the wall's capacity, you can certainly ensure that how that can be that can be controlled. So for doing that, you can use statistical approach to predict the overall heat load from each product type, and then you can use one store needed at that point in time, so that you can be able to save millions of pounds. So if you generate that model specifically for one store, you can certainly limit the overall energy consumption of other stores, which can help them solve or save millions of pounds. So this project, as we call it, lasted for almost 6 weeks, and the intent of that project was to do the diagnosis, to do a data preparation, and then provide solution and the kind of report. So it took almost 2 to 4 weeks time, and as we call this as we call and look into this example, this is perfectly an example of a weak AI, wherein you try to use the artificial intelligence in the operational research area, and then you try to optimize the overall cooling facility of that area. And then certainly the duration of 6 weeks will be helping the overall organization in saving some cost and bringing some kind of value in the overall process. Now let's try to look into the other example, and let's try to look more deeper into it. So if you see this graph, the graph clearly shows that the vault A and vault B, how the overall heat was generated, how the overall heat usage was restricted, and what was the total of heat generated over a period of a couple of months time by these, right? So this example, as we call, is one of the example of the usage of narrow AI in the overall system. Now let's try to look at the second example, which is an example of how we can think of modeling of atmospheric turbulence, right? So this was one of the long back model which was provided by Da Vinci to identify the red spot on Jupiter. So this example, as we call it, can be used through the likes of artificial intelligence, and this is one of the example of the strong AI usage. So as we call, the description turbulence, which can have a non-linear enhanced mixing, and you can use the likes of randomness and vorticity. So obviously when you're trying to solve and create the model or build the equation for these kind of things, you need to use the likes of big data, the statistical analysis, and then high performance computing, because the overall amount of data which get generated is relatively very high. And for analyzing that kind of data, you certainly need to have the high level computational machines and the right set of algorithms and big data lakes to use that kind of information. So again, this is one of the equations which was presented across. So we are assuming that the potential energy from the fall is transferred to the kinetic energy and dissipated as heat. So they tried finding or trying to use the model. They were trying to build a model for Jupiter by using the examples of Niagara Falls, how the overall energy which get generated as part of Terrapin Point, Horseshoe Falls, right? And in terms of the Ontario city, so how much is the overall distance and how much is the overall height, right? So if you see the crest line, it is almost 2,500 feet high, which is close to 762 meters, and the overall daytime height, as we call it, is 167 feet, which is almost 50.9 meters. So this set of information help them to understand that what is the overall velocity at the bottom of the fall, right? So when water moves from the top of fall to the bottom, right? So it travels at a speed of almost 31.63 meters per second, and you can always try to create and generate the overall turbulence level. So the turbulence dissipate almost 1500 megawatt of energy, which is absolutely high amount of energy which can supply electricity to whole of North Wales. So that's how we can think of modeling the atmospheric turbulence with the likes of machine learning algorithms, and it has been used it has been used by likes of Da Vinci for quite some time. So similarly, in this slide, we can always see that how the likes of AI algorithms can be used for uh, taking the overall uh, pictures by NASA, and how certain predictions can be made by the likes of NASA based on that. So how the overall hurricanes which exist and which get created, so they try to predict the hurricanes, they try to predict the overall uh, overall uh, NASA engineers and NASA scientists, they try to predict overall atmospheric pressure and temperature of various other planet with the likes of these models, as we call them across. So these are all examples of strong AI usage, wherein how the information which is present to us can be used to solve some complex problems with the likes of AI algorithms, and then can can help you come up with some of those problem solving. So so as we again see deeper, right? So why study any two-dimension simulation? So as we call it, in ocean, in studying the ocean science, as we call it across, right? So we can always try to use 2D or 3D kind of analysis, specifically for doing any kind of simulation. So how the the temperature in atmosphere and the temperature in ocean, we call it oceanography, right? How it varies, and how the overall waves get generated across. So we can try to put simple model to the mathematics, and obviously these models which we put across can be created with the likes of AI, and there would be requirement for large computer resources. There has to be large ratio analysis, lots of realization, lots of simulations. So there all these things will be required to analyze the overall data which get created with the likes of AI algorithms and various use cases. So if you try to do any kind of 2D analysis with the likes of CFD, so you can always try to create some hypothesis which can be basically analyzed with the likes of AI based algorithms. So for any kind of high performance computing, as we call, there are various supercomputers which are available across, and these supercomputers, which helps you to do the high performance computational analysis, can certainly be of use, because there is loads and loads of data, thousands of gigabytes or petabytes of data being used across, and then these data can be analyzed by the supercomputers and the likes of high performance computational machines. And so you can always try to create the model. You can start with creation of the model, then you can think of maturing it, and then certainly how the matured model can be used across. So obviously AI and ML can be of great help in this area, because AI and ML have the capabilities of utilizing the high performance compute, and then they can use the lots of generated data volumes to feed it across, and that's how it can be of a great proposition to use AI and ML in solving these tough problems, and we call them as solving the complex problems of atmospheric turbulence, and then we call them as a strong AI use cases. So again, uh, how the data was used for almost 2 years for preparing the overall data analysis, right? So statistical tools were used for weeks and weeks together in terms of ensuring how the right set of data which was captured over a period of time was presented across, right? So as we call and as we see, it's one of those perfect examples of how humans and machines can certainly work in harmony, and then they can help humans solve some of those complex problems. So machines did the heavy lifting, leaving humans to build the hypothesis, right? So most of the complex problems were resolved by the algorithms of artificial intelligence or machine learning, and then humans can certainly be involved in building the right set of hypotheses, doing the kind of analysis, and representing back the interpretations of the results which is there. So it's one of the perfect examples where the harmony between machines and human can be used for the betterment of the world.